You hear that part, we have counselors in the hall and recreational drugs for that. So also at the end of the talk, I'm going to start talking about restoration in a big way that we're doing pretty much all over the state. So there's actually quite a bit of hope in this. Oysters are really cool. If you think seagrasses are cool, boy, oysters are really cool. There are no other organisms I can pretty much guarantee you in your life that you will encounter that are both aphrodisiac and navigational hazard. So this is a map. This is a map of Cedar Key, or a picture of Cedar Key. Pretty much everything you see in that satellite photo is actually structure created by oysters. They are modifying, creating habitat in every major estuary in eastern North America. So they are really an important species. You can actually try and tally up what they're worth. I'll show you a little bit of that later. One of the keys to understanding eastern oysters, Crassostrea virginica, is that they are the estuarine oyster. Most oyster species in the world grow in ocean-strength seawater. And the eastern oyster really doesn't. It really does really well in this range, maybe 15 to 25 PS practical salinity units. As you get up in salinity, they become physiologically more stressed and become more vulnerable to both predation and particularly to disease risk. And so if you keep them for any length of time up around ocean strength, whole reefs will often die. The same thing happens at really low salinities. Their response is simply to shut their two valves and do nothing. That means that they don't feed. And if the water's hot at that time, they'll die pretty quickly. So as an estuarine oyster, they can tolerate both extremes for short periods. That's their habitat. But this is where they need to be, and that turns out to be really important for their management and understanding their declines. Oops. Okay, this was some now dated information that is about how much the Army Corps of Engineers thinks these things are worth. And it's just to illustrate that at least for protecting shoreline, oysters are worth about $1.5 million per hectare per year. A lot of these other things, which are fisheries production, blue carbon, water quality, and biotic diversity, are probably vastly underrated, and it seems like every month there's a new paper coming out saying just how valuable oysters are. So I won't dwell on that, but they are something that we really need. Yet they are probably the world's most endangered marine habitat. So this is a study done some years ago now, but it really was worldwide, and it illustrated that the vast majority of populations in the world of oysters are either simply gone or are functionally extinct. That is, they don't do any of the ecosystem services that they used to do. One of the few remaining places in North America is the Gulf of Mexico that was said to be fair and have some populations that were both harvestable and were and had important ecosystem function left. So this is one of the last great places to deal with wild populations of oysters. A lot of the threats to eastern oysters are in this list, and you can probably imagine the vast majority of them. But one of the reasons why I want to dwell on this slide for just a minute is that many of these are interactive. Many of them are happening in the same place. And we're not talking about an oyster. We're talking about oyster reefs. And the things that they can do really decline with the population. You can very frequently get into this sort of ball and valley situation where whether it's resilience you're talking about or switch to an alternative stable state, once you get to that new state, it can be very, very hard to push it back. And it's because these oysters are creating habitat for themselves. They're very strongly enhancing habitat for themselves. Oops. So here's the bad news. I'm pretty sure we do not have yet an active statewide monitoring program. We are, as you pointed out, pulling together everything that we know about oysters in maps throughout the state. But in terms of anyone going around and monitoring in the same fashion around the state, and particularly historically, we just don't have it. So even in places like Apalachicola, which is the state's main fishery, we don't actually have historical acreages. We have some indication from the 1850s about the extent of the reefs, but then in most eras since then, we don't have really anything. We have harvest data, but not much else. So in every major estuary that we know of in Florida that has been studied, we've seen at least a 50% decline in acreage of the oysters since the 1950s. In the case of Big Bend, that's since the 1980s. In the case of Charlotte Harbor, it's almost certainly since the 1980s. So they're going down fast, really fast. To give you an indication of how fast, this is the lone cabbage reef off the mouth of the Swanee River in 1982. And as I click through these, you can see that's 1995. These are about the same tide level. That's 2010. So these things are going down fast. We know that this reef in particular was there for at least 3,000 years before the present time. So it had to have gone through a lot of ecological variability, and yet the last 30 years have just been decimating it. And I'll go into a little bit more about why. In Apalachicola, we're really talking about two main things, which are decreased freshwater flow, and the state of Florida has gone to the Supreme Court to try and get that freshwater flow back. They haven't. And we also have this negative shell budget, and I'll talk about that in a minute. That is the fact that the bed itself is declining because you're not producing enough shell to keep it built up at all. In Big Bend, we're pretty sure this is due primarily to decreased freshwater flow and a salinization of that estuary, leading particularly in drought years to die-offs of entire reefs, the shell then dispersing and then not having any habitat to get those oysters to spat back onto. In Charlotte Harbor, it was at least initially shell mining, wholesale taking of entire reefs to build roads and things with. But then also we've had, both in Charlotte Harbor and in the Everglades estuaries, we've had major pulsing of freshwater flow. Kind of the same thing that's happening in Florida Bay, where you have sometimes really big fast pulses of fresh water, often nutrient laden. And then when it's dry, you get a super drought because people are trying to use that water. Along the East Coast, Linda Walters and her group at University of Central Florida have demonstrated that boat wakes are actually really, really important for just flat out eroding oyster bars, oyster reefs along the Intracoastal Waterway in particular. But there's also now evidence of eutrophication causing anoxia and die-off of those beds. So there are certainly other populations of oysters in Florida. These are some of the best known. There are a number of feedback loops going on in these die-offs that are really pretty nasty, but you've got to recognize them if you're going to restore these reefs. So the first is, I think, what's going on in Apalachicola, what we call negative shell budget, which leads to, because of harvest, you're removing shell, you're not putting it back for the most part, and it leads to a reduction in the altitude, the height of that reef. That puts oysters back down in a zone where they're more susceptible to anoxia, and their growth is less. When you combine it with harvest, continued harvest, you essentially have not enough shell being created to keep that reef even stable. It just keeps going down. So this is the story in Apalachicola. It's the big story in the Chesapeake. Negative shell budget is a real problem in Apalachicola, and even some of the most recent investigations into this suggest that you can probably, even on a healthy reef, have no more than 5% harvest in order to have a stable shell budget. So this really calls into question how much we can harvest oyster reefs and not simply have to maintain them in a very expensive way over time. Another one is nutrient pollution that I mentioned, where you get algal blooms as a result of too much nutrients in the water, which leads, of course, to anoxia, which leads to oyster mortality. Well, once you do that, you've reduced the filtration capacity of these oysters. There are lots of debates about how much oysters really do filter, but in the end, even if you take the low rates, that lone cabbage reef in its healthy state could filter as much water as Miami uses in a year. It's a very powerful biotic tool. So once you lose that, you then get a negative feedback because it's not filtering as much algae. You also, by the way, are losing, just like in lone cabbage, you're losing all of that shell, and then you don't have a place that oysters can spat back onto. Okay, the last one is really the lone cabbage example, and that is that even in a short time span, you can have a very healthy reef, which if you have prolonged periods of high salinity that are exacerbated droughts, essentially, exacerbated by human water use, you get these episodic mass mortalities, and if you have enough in sequence, you can begin to lose the shell on the surface of the reef. Once you do that, once you've lost that substrate, that reef ain't coming back no matter how good the conditions are. We have loads of larval supply in this area, and yet they can grab onto tiny little bits of shell hash on here, and every single one of them gets eaten by a blue crab. So there's literally no refuge. Okay, so that's kind of the end of the bad news. The one thing we do have in Florida is, for the most part, we have good larval supplies still. This was a rather frightening experiment to me, where I put over an anchor in June and pulled it up after 3 months. And I had some of those are 5-inch long oysters. These things grow frighteningly fast. And if you really have substrate out there and can catch those spat, you can get instant oyster reef. There are lots of ways to do this. We've been doing this for over 300 years, putting out shell. This is the main method in Apalachicola. And it is tremendously effective. However, that shell is actually pretty light in the water column, and it can be moved around by anything like strong currents or a lot of wave action. So this really works for sounds in some bays, but exposed areas with high current, it doesn't work very well at all. The stuff just washes away or gets buried in softer substrate. But that is a major technique. The other end of the spectrum, this is again Linda Walters' stuff on the east coast of Florida, where she had a very high energy environment, boat wakes, and she actually got hordes and hordes of people to sit here and make these little mats of every single one of those shells has a hole punched in it and a cable tied through it and tied to a mat and then staked down and anchored down, and these are hugely effective. So there are methods to do this in high energy environments too. Very labor intensive, but it can be done. There are a huge, almost an explosion of techniques and materials for creating substrate that have happened largely in recent times. These oyster castles are modified cinder blocks that you can create continuous or discrete little mounds, and you can get vertical growth very fast with these things. This oyster catcher is a now proprietary method where you take jute and you twist it or wrap it into shapes and then dip it in a concrete solution and then put it out. And that also is very effective. We've used clam bags in Cedar Key that are derelict clam bags, and they've got lots of shell inside them, lots of culch, and you can see them bing, bing, bing on a derelict oyster, on a degraded oyster reef. They suddenly pop up with oysters. Lime rock boulders we've used a lot in various sizes and shapes, and in higher energy environments, a large boulder will really stick. And then finally, the Dutch have invented this biodegradable potato starch matrix that was invented for mussels, but works really well for oysters. Lots of great interstitial space in here for small oysters to catch on and grow in a predation-free environment. There are big-time restoration efforts going on in Florida. Apalachicola Bay, Everglades, Charlotte Harbor, all of these places have some major restoration effort going on. When you look at the acreage over here on the right, it doesn't look like a lot of acres. But remember that oyster reefs are very often long and linear. And so, a 2-mile or 3.5-mile long reef may only be 10 or 15 acres. So this is actually very substantial restoration. There's a lot of different techniques being used, but mostly these things are being pretty effective. Most of these are current, by the way. These are things that have just started up. The vast majority are funded by funds from Deepwater Horizon. Okay, you can get some quick results. We've gone from essentially a sandbar on Lone Cabbage Reef to the highest or second highest, depending on how you measure it, oyster densities in the Gulf of Mexico in either restored or natural situations. You can do this quickly. The nice thing about this is that we actually have the larval supply. But remember why a lot of these things started to go extinct. Almost all of them had some kind of a problem with freshwater discharge. And so in Apalachicola, it was probably too little. In Big Bend, it was too little. In Charlotte Harbor and St. Lucie Inlet, it was probably pulses of unnaturally timed water. And in general, it was the too much that was killing them. If we don't pay attention to this upstream water management as being a prime, really important driver of what's going on with oyster reefs, all our efforts at substrate limitation are not going to pan out eventually. And so I think this is the frontier for where we need to be. Lastly, I just want to point out that this is Lone Cabbage Reef and this is the Swanee River. Most of the reefs in this part of the world, we don't have offshore barrier islands because they are, we don't have enough sediment load coming out of the rivers. These function as barrier islands. These function to entrain fresh water in these bays. So these are the offshore barrier islands. My point is that you're not going to do much by restoring just one little piece of one of these reefs. You got to do the whole schlemiel if you're going to do anything. It's also true, this example illustrates that we may be able to use oyster reefs in the future as coastal engineering tools. They can outgrow sea level rise by a long shot, and we may be able to direct water and save some of that fresh water, or at least detain it in estuaries that are currently salinizing. So to finish up, we do need a statewide monitoring plan. That, I think, is in the works with Fish and Wildlife Commission, but it's something that we desperately need. We have rapidly declining reefs in every major estuary and evidence of ecosystem collapse in some. The fishery in Apalachicola Bay has now collapsed. They're down to 3 bag a day limits. You can't even pay for gas with that. And all of those fishermen virtually have moved to Cedar Key now. So it is collapse. We know how to deal with a substrate limitation. We need to now focus on those freshwater inflow issues. And this is an issue for everything that lives in salinized estuaries, which are now becoming common throughout the Southeast. We've got, the good news is we've got major restoration projects underway, and we're learning buckets from those. And then finally, just a plug that we may want to think about using reefs as engineering tools in the future. Thank you.
We have time for 1 or 2 or 3 questions.
Yeah.
What's the dispersal range of oyster larvae, and do you think they're coming from somewhere within the Florida system or somewhere further away?
Well, I'm not a very good larval ecologist, but I can tell you that a lot of places like Chesapeake Bay that have pretty much lost any real populations that produce larvae simply don't have spat set anywhere in the entire bay. So they don't come in from outside the bay. Along the Florida coast, along the Gulf Coast of Florida, we're pretty sure that many of the larvae are fairly local, and that's because they're only in the water column for maybe 2 weeks, and they tend to start settling out fairly soon after that. Yeah.
Yeah, I'm glad you mentioned the underlying cause of a lot of the decline in our oyster populations throughout the state. That's the proper freshwater flow because, excuse me, I'm cold. You know, we've been doing oyster restoration work in Sarasota Bay as well, and make sure I get that information to you. But unless we really address the problems, a lot of the restoration work is feel-good work. It does have an effect at a relatively small scale, but ultimately it's going to fail. It's like pushing that rock up the hill. So we have to continue to address the flow issue so that these oysters can thrive. Like any restoration project, if you have the right environment, once you get it started, it'll take off on its own, and that's much more cost-effective than what we've been doing, you know, to now. So hopefully we'll continue to address the issues.
I agree with you. I think there are some places like the sandbars that I was showing you, where I mean, even in freshwater years, we'd get no spat set out there. And the reason is because we have a real substrate limitation. So I agree with you about the ultimate causes.
Thank you, Peter. Remember, we're going to have a 30-minute wrap-up, so plenty of time for more questions.
Thank you. So our next speaker, Brian Walker from Nova Southeastern, is going to talk about coral reef and hard bottom community biogeography